Hello, my name is David Ackerman, student number 220-310-629, and this is the McDynamics assignment 2, mandatory. Let's get started. So here is all the problem, here is the diagrams, so on and so forth, and now we're going to solve for part A, which these are the givens, that these are the givens, the gear diameter, the gear dimensions. The assumptions is that there's no slipping and there's no stretch at the gear chain. This is a free body diagram with the radiuses there. And for A, we're solving for the angular speed gear D at times equals 3. So VA equals VD, VA equals WA which is a radius, which is the dimensions of the radius A. Thus the angular speed of A times the radius of A. The VD equals that we're substituting the time variable for the angular speed of A times the radius of A. And now we are solving for the angular speed of D using all these that we know, and then we plug in time equals 3 seconds, the radius of D, and then the radius of A right here, and then we get the angular speed of D equals 300 rads per second. B, well, these are the givens, which is the exact same. The assumptions are the exact same, that there's no slipping, no stretch at the gear chain, and this is a free body diagram. So now we were given that the angular speed of D equals 300 rods per second, which is the angular speed of B. VB equals VC. VB equals the angular speed of B times the radius of B, and then the angular speed of C equals the angular speed of B times radius of B divided by radius of C, which is a formula that we just divided the radius to isolate for the angular speed of C. We're plugging in all the known variables, which is 100 millimeters, which is 0.1 meters, and then 50 the radius of C, which is 50 millimeters, that is 0.05 meters. And then we're plugging in that the WD, the angular speed of D, equals 300 rads per second as calculated on the top one. We get that the angular speed of C equals 600 rads per second. And now which one would be better? So the new gear system with intermediate gears B and C can reproduce the pedaling effort by lowering the torque required by each stage, addressing the operation fatigue by reducing the load. It becomes easier and for less capable operations to pedal, which means that you're going to pedal a lot less and be going at the same speed. If the gear ratios are chosen well, meaning that the gears are properly chosen, the new design will reduce effort while maintaining the performance, meaning that because there's more pulley systems, that meaning that effort will be lower, that meaning that the speed could be maintained at the same pace. The engineers should proceed with this design because it proves its effectiveness based on the calculations and conceptual activities. Thank you for listening, and this is the video.